Okay, so I'm gonna talk about adding fractions and just a little easier way to do it other than standard algorithm. So I have 3/4 plus 2/3, so don't pay attention to that. 3/4 plus 2/3 up here. And I look at it and I'm gonna say, or I can represent the 3/4 and 2/3 by using sets of 12. So I can draw out my 12 dots, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is one set, so I circled that set. And then I look at it, and I need to be representing 3/4. So I have 1, 2, 3, 4. See, 1, 2, 3, 4 groups. So 3/4. So I shaded in this last group. And so if I just look at what's not shaded in, that would be 3/4 of my set. And then I can draw another set to represent 2/3. So I draw my 12 circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm getting 12 because 4 and 3 have a common denominator of 12. So once again, I shaded in this last row, and if I cover up that last row, you can see that that represents 2/3 because there are 3 groups and 2 of those groups are not shaded. So now to solve this problem, if I have no idea what to do, I have my 12, I represented my fractions, and now I need to count the circles that are in this set that are not shaded. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 12s because there's 12 dots in all. And then I can go over here and do the same thing. So I have 1, 2, 3, 4, 5, 6, 7, 8. So that gives me 8 12s. So then now we can see that this denominator is the same. So then we can go about adding or subtracting that. So I have 9. And I could just add that straight across. Or I could even go back and count all, I can count the dots on this, in this set as well as in this set. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And we know that 9 plus 8 is 17. So I have 17 over 12, which is an improper fraction, but for this case, we're going to leave it like this. So that's just one way to show you how to work that out. Just using, you could even use manipulatives such as counters. You could use any type of cube, square, circle, whatever you want to use. And you could set it up like this. And that way the student can physically hold the fractions, really. Hold the fraction, hold the problem. I think that would really help the student understand what we're looking at, what we're dealing with, what we're trying to solve, and then seeing this end product. So that's just one method that I found useful after reading this chapter, and I think that many students could use this, and that it would help them instead of using just only using standard algorithm. Thanks.